again, I don't need to spend time on this. Everybody knows the name of Tim Berners-Lee, or some people have not heard of him. I think some people have not heard of Tim Berners-Lee. Tim Berners-Lee was a physicist, by the way. He worked in CERN. CERN is the famous nuclear research institution in Switzerland. And he had a problem. He had, by that time, internet was working, but he had to transfer files. Now, I will describe this problem. It was very interesting from a perspective of an end user like you, and also to tell you how sometimes great computer scientists simply fail to appreciate the end user's need. He is a physicist, he is a researcher. Now, he wants to compare notes on a certain theme which has been published by, say, 20 different researchers in the world. He knows their names. He knows that their papers are available on some internet server somewhere. He will ask them to transfer files. So 20 people are transferring fact files to him. One file is 200 pages, another file is 20 pages, third file is 34 pages, etc. etc. In each of the files, let's say he is talking about neutron acceleration. But that neutron acceleration may be either a section or a paragraph or a page or 2 pages in each of these files. After receiving all these 20 files, he will have to read through all the 20 files, then extract those portions which describe the neutron acceleration, and then collate them and understand what this fellow is saying, what that fellow is saying. His requirement is the ability to decipher some portion of a larger material which is available with somebody, similar or some other portion from some material from somebody else. That is his requirement. And the only thing computer science community was able to give him is FTP. So you can transfer files. He says, I don't have lifetime to spend only on transferring files. I want to read, understand and apply my mind to improve on some portion of the knowledge. And there are portions like this which are commonly referred to by all nuclear scientists. Can I therefore not have something better than this? This was the genesis of the birth of web. Till then internet existed, files could be transferred, emails could be given, etc. There was a need for large teams of physics researchers to share portions of reports, portions of drawings, portions of photographs. The only thing available, as I said, is copy multiple files and then search. Tim Berners-Lee, a physicist, not a computer scientist, got very desperate after talking to many computer science people, partly gave up physics and started learning computer science to be able to do network programming that was required, and developed a completely new protocol called Hypertext Transmission Protocol, and developed a new specification language or a scripting language called Hypertext Markup language. Everybody understands what a markup is? Markup is a term of copy editing. You know what copy editing is? Suppose you write a paper and you give it to a publisher. Then that publisher will want you to say which font size, where the paragraph breaks, where editing is to be done. Editing typically insert something, delete something, is indicated by marking on top of your text. And that is called marking up. Let me just give you a simple example. It is important to understand the history. So for example, suppose I wrote this. This is sentence, and I forgot to write this is a sentence. So this is the text which I have given. The editor, proof editor, a friend of mine, will mark it up. Will say this, and will say A. You agree with this? This is a common representation of insertion. Now this insertion symbol here and this insertion followed by text is considered a part of marking up. The original text, I am marking up that text so that the markup stands out and you understand what is to be done. A printer, for example, will understand what is to be done. He will insert A there somewhere, or a typist will understand, or a clerk will understand. So this markup is meant for rendering a text in a better form, including corrections, additions, whatever. This notion of markup has existed in proof editing perpetually. The markup is not necessarily for insertions and so on. For example, there is a sentence, let's say, went there, they found something, something. Okay. I may want that there should be a paragraph change here, no insertion. A typical symbol is this. Some of you may be aware of this. This means take this to the next paragraph. I might want to underline found. This underlining is markup. I want some word to come in bold. I want some portion to come in larger font size. These are all proof editors markups which are required to render the text, let's say, more beautifully, aesthetically, elegantly, etc. He picked up that notion of markup and said, let me prepare a markup language, let me define a markup language which permits people to publish the text on their own site, but keep it with markup so that I should be able to understand what they mean. Remember, if you had a text page which is printed, on that printed page there could be bold, there could be font which is different, you could see that. But when you transmit it only as ASCII characters, all will appear in a mundane form. So a file which is transferred, you will not be able to understand it. Remember, we are talking about days before the so-called word processors were uniformly understood or uniformly available. And Europe had one word processor, Japanese had another word processor, so they could not understand each other's files. So he had to have this markup for proper rendering. And in addition to rendering, he defines the hypertext markup language and a hypertext transmission protocol. The key was not only the markup, the key was so-called hypertext. What is the notion of hypertext? He said that I want to concentrate on a specific portion of the material that he has written in his 200-page paper or he has written in his 20-page paper. Now suppose he also understands what could be of interest, and let's say there are 10 themes in that large paper, some 12 themes in some other paper, 5 themes in my paper. While writing the paper, if I could mark each theme by a special text, which I call hypertext, which means this text itself does not mean much. But if I click on this text, I should be able to go to that theme. And he conceived that each such hypertext should be actually a link to a separately stored page somewhere. In short, he enunciated the principle that if you are writing a 30-page document, don't write it as 30-page document, write it as, let's say, 18 different documents. Each document stored as a separate link. And create a single page containing all these 18 links. Transfer me that page. When I see that page, whichever link I want to go to, I will click on that, and I should be able to communicate with your machine containing that particular page, get it back to me. This was the great conceptualization that Tim Berners-Lee made at CERN. He proposed HTTP and HTML between 1989 and 1991. You can see how recent the whole development of web is. It's just about less than 20 years old. This alone was not sufficient, because by putting up this HTML hypertext and putting up these links and defining the protocol, at best you could guarantee that material will move from one place to another place very easily. But will it be shown to be in exactly the same way that it is seen by him there? Now that required common piece of software. Just as if you have a Microsoft Word document, you require a Microsoft Word at the other end to open and make sense out of that document. Or you have a spreadsheet of, say, some other tool, you require that spreadsheet. The world needed some kind of a common tool which will look at this HTML file coming through HTTP protocol and show me exactly the same thing as it originally intended there. This task was done by Mark Andreessen. He was working in an organization called NCSA, the big standards organization in the United States, and he built the first browser. All of you are familiar with browser. Before the notion of browser was known, he built the first one, which was called Mosaic. This was built between 91 and 93. In 93, he realized the potential of this browser, and he told the United States government that let's convert this into a product and sell it universally. But government being government, they said we don't think it will be useful. So he actually got disgusted and left the job. He left the job, went out and set up a company called Netscape. So he is the founder of Netscape. Rest of it is history, as you know. The whole world is different today because of these two great inventions. One invention by a physicist on setting up this kind of mechanism, another by building a browser. Netscape browser was the only one. Now you have plethora of browsers. Fortunately, all browsers now must conform to certain standard which is defined by a committee called World Wide Web Committee. It is called W3C committee. That body now standardizes so that the commercial maramari between different people that can go on, innovation can go on, but every browser is required to comply to a W3C standard. And HTML, script or other XML thing, whatever else, as long as you write it using W3C standard, it is guaranteed that it will look and feel the same way on any machine that you see. So Mark Andreessen developed this in 93. So 1994 actually is the birth of World Wide Web. It started with 91. By 94 it had enormously progressed, and now practically every household can have a web server which can be used to connect to any number of people. There was some early growth rate. The number of systems on internet were growing twice every year, exponential growth. But the worldwide websites were doubling every 6 months. And this trend continues even today. This is very old statistics. I don't know what the numbers are. Maybe you would like to find out from some internet source. So basically, the World Wide Web, or WWW as it is called, it consists of hyperlinks which are distributed documents. The location and address of each document now becomes an important part. Remember, so far we are talking about only host addresses, but now we have to talk about location of a document. That document is identified through what is known as Uniform Resource Locator, or URL. You are all familiar with URL. So URL is the way you identify that, and because this URL can contain anything, it can contain multimedia data, it can also contain software. So you can actually take a piece of software from somewhere else and run it on your machine. The World Wide Web therefore has made this software mobile. In general, the most mobile portion of such software is a set of programs written in Java programming language. I mean, Java was created by Sun, but it has become the most popular network programming language. And small programs which are not standalone applications, but some sort of small stubs which do something here, something there, etc. These are not called applications, these are called applets. So the Java applets, okay, are typically the most important pieces of small software which move from one URL to another, execute on that machine and do some useful work. Now comes the reason for our discussing this. Remember, we said at the beginning that our information systems will comprise of some large database server or servers at the back end and some end user front end screens. So far we are talking about generic screens where SQL queries can be run, results can be seen, etc., etc. What should be the interface that end user should have to the machine? What kind of screen software one should use? If you are using COBOL programming, you can draw screens using COBOL program. If you are using Oracle database, Oracle provides a tool called Forms. The problem is, if you are using Oracle Forms, then the Oracle Form software must be loaded on your machine, even though the Oracle database may be somewhere else. The moment Oracle Forms changes its version, you have to reload that software on your PC. And in short, your PC itself has to be a strong machine in order to run all the end user software. Because browser became available easily, and because browser was almost a de facto component of every operating system, people said, why not develop software which uses only browser at the front end? So whatever browser can do, I will do. So let us make browser more powerful. Let me fill up forms in the browser. Let the browser take care of my input, send it back to a database, let it establish connectivity. Since Java programs run on my front end, the Java applets, let me have a connectivity between Java and a database. That is how Java database connectivity or JDBC evolved. Going forward, it is unthinkable that any new application will ever be constructed without being completely browser enabled at the front end. Because there is no reason to have plethora of software unless you are doing some very specialized application. What could be that specialized application? Let's say you are doing 3D animation of a car design. Now that requires a heavy graphic engine, and the current facilities available in browser will not permit you to run a large simulation engine at the back end as of now. Going forward, even that may be possible. But 95% of the general applications can be written, developed such that the front end is a browser front end. You use that browser front end, connect to either a database, this, that, or whatever else you want to do. Through browser you can send emails, through browsers you can receive emails, you can do most of the activities, and therefore browsers have become a standard. Consequently, a server which contains information, which will have an information resource like a database server, it will also have an HTTP server. Remember I mentioned the protocol, Hypertext Transfer Protocol. A protocol has to run at two places. When it runs on a client, the HTTP protocol is submerged inside a browser. The browser effectively runs the underlying HTTP protocol. But when you are looking at a server to which multiple fellows may connect for services, then you call it an HTTP server end protocol. So consequently, HTTP has a server. When you say HTTP server, does not mean a physical machine. It means a process which works at the server end. Clients, on the other hand, interacting with one or more information resources, could use browsers. This is the basis of all modern information systems. And that is how you would expect these systems to be constructed. A URL contains three components. Uniform Resource Locator. It contains the name of the protocol, which is also called the scheme. It contains the name of the DNS server, and it contains the local unique name of the page. The protocol could be HTTP, FTP, file, news, telnet, mail to. You will often see in your browser HTTP:// something. That HTTP is the name of the protocol. You will also say FTP:// something. That means you are using an FTP protocol. So the name of the protocol is stated there. This Hypertext Transfer Protocol is an application layer protocol. It has an ASCII request reply based kind of structure, and you write this as HTTP:// host, optionally port, optionally path to resource. All these together will mean a complete specification. Incidentally, how will you interpret when you have HTTP:// www. Let's say csc.iitb.ac.in. That's all you write, nothing else. What would it mean? You are trying to open up a page on the CSC server because you are specifying only the host name. Okay, www. Or let's say www.iitb.ac.in. You are specifying only the host name. This is a URL you are. So this particular thing will be translated through a DNS server to an IP address, etc. But what is expected on that IP address is not an arbitrary thing, because the protocol is HTTP. Since no port is specified, you will go to the default port for HTTP. Since no path to resource is specified, on www.iitb.ac.in, this request will connect to the HTTP server because the protocol is HTTP. So there are lots of defaults which automatically work for you, but you can always write very specific things if you wish to. Here are the message types in the protocol. There is a request message which could be invoke a method called get or post, and there is a response message which will tell you the status of request. It will contain the message body. We will not go through the details of HTTP protocol itself. Those of you who are interested can again check up. These are various methods. Method meaning a procedure or a program. So these are the procedures or programs which are available as part of that HTTP protocol. Get, head, put, post, delete, link, unlink. We will not go through the details of this. Let's now quickly look at HTML or Hypertext Markup Language. The Hypertext Markup Language does a markup which is an old copy editing term. The purpose, as I explained, is to mark up the document with special tags. The purpose of original markup was to add these special tags to tell the printer which font to use, how many margins, paragraph breaks, etc. In short, these tags describe the look of the document. Consequently, the entire HTML is not about the semantics of meanings of the content, but of the looks of the content. It is called rendering. So HTML defines how a document should be rendered or shown on your screen. Consequently, there has to be some agency which interprets these tags and does rendering appropriately, The interpreter is your browser. In short, a browser's fundamental capability must include the ability to understand HTML tags, interpret them properly, and display the contents accordingly. That's the fundamental requirement. So there are explicit formatting commands which are embedded within the document, and browser acts as an interpreter. It interprets HTML tags, it can handle tables, formulae, has advanced style sheets. So if you want to describe a whole lot of formatting, instead of describing it in every document, HTML, by the way, once you include HTML in any document, the document is called an HTML document. It will contain normal text and it will contain these tags. Now, if there are lots of tags describing what font size, this, that, and you have to use the same tags in multiple documents, you rather extract those tags separately and say apply all of these to this document. So when you apply these separately, these are known as style sheets. So you supply a document, you supply a style sheet identity and say interpret this document as per this style sheet. So within that document there may be some tags, but the style sheet will give some generic thing. And then you can do fancy stuff. I can send you a document and give you a reference to a style sheet which is stored on his web page. So I'll give you a URL saying take this document, but let your browser interpret this document using the style sheet which is located there and show me everything. Since all web servers are supposed to be connected permanently and perpetually, this thing is possible. These are some of the tags. I will not go into too many details. I think everybody knows some basics of HTML, or no? Some people have never seen HTML. So let me quickly go through this. The typical way of describing an HTML document is to enclose any material which you want to be understood differently between a tag and a slash tag. So this is the beginning, this is the end. For example, the whole HTML document is enclosed in HTML/HTML. There are two parts. One is called the head, which starts with head, ends with, there is some problem here, syntax error. The greater than sign on this side should be there correctly. Here is a simple example. HTML/HTML. So this is the whole document. Then head, within head title, simplistic HTML page slash title. Slash head, that means head has ended. Body, hello world, end body. You can actually give this page, store it in a file and give that as a reference in URL on your own browser. And you will suddenly see simplistic HTML page coming as a title somewhere and hello world coming there. What should be the font size? Where should it appear? Okay, what should be the type of font? All these things are not prescribed here. Obviously, HTML says if you don't prescribe anything, there are some default assumptions I shall make. Those default assumptions are common sense assumptions. If you want to specify something else, you can always do that. So, okay. In a PowerPoint slide, this is actually a URL. So if I click it, you are supposed to see that page. Notice that it is displaying the link. The link says c:/documents and settings /this something s18-htm whatever. Unfortunately, if I click here, nothing happens. Cannot open the specified file because the file exists on my machine. I brought the slideshow, but I did not bring that file and did not load it in the same directory which is named. So if you correct that, you should be able to do that. In fact, one exercise could be on your own machines. You can try doing this, setting up links, etc. Here is another thing. You can delimit a title. H means header. You can have header 1, 2, 3, 4. They are all defined font size. B means bold. I means italic. Underline. UL/UL. Okay. This is unordered and numbered list. So OL and UL. UL means unordered, OL means numbered list. So if you say LI, you start a list item, LI, you give various items. They will automatically come as separately listed items, either unordered or numbered. A BR is a line break, P is a paragraph break. Okay, here is an example. Title is less. Body, H1 is the header. Example of unordered list. Please note that when I put things between // this is a comment for HTML. HTML will ignore that. Type is fill around. This is a specification. SQL, relational algebra, network basics. So these are 3 items in the list. They will be listed as an unordered list. Okay. A ordered list is you say OL. OL is ordered list. In ordered list you say type equal to I. I means numeric but Roman numeric. And start equal to 4. So what will this produce? Any idea? If this is the HTML document, since start is equal to 4, the first one it will say 4 and it will say SQL. The second one it will say 5 in the next item. Third one it will say 6 in the next item. You can see how rendering can be made meaningful by simple markup tags. Okay, you need not change the original text, which may be just an unordered list. You can order it. I am not going into details through HTML, but I would strongly suggest that HTML, unlike all other parts which are heavily technical, HTML is very simple to understand. And I would recommend that you actually spend some time constructing. Best thing is go to any page, any web page, and look for the source code of that web page. A large chunk of that web page source will contain unfathomable information, where it will come from the style sheet here, there. But if you have some simple web page, you can actually decode what these different tags mean. It's an interesting and simple exercise, so I am suggesting that. Okay, here is how you define a hotspot. You remember we said hyperlink. Now you are constructing a document and you want to create a hyperlink, just as the one I had tried to create in my previous thing. You click on it, you go to a resource. How do you create a hyperlink? You do that by saying href. So when you say href equal to some URL and put some text, this text becomes a hyperlink. For example, href equal to URL, whatever URL, image source is URL. These things become two, what should I say, a source of an image. That image will be displayed by the browser. Okay, here is how you describe a menu, its description. And menu has multiple items. You choose one item, some page will come. Choose another item, another page will come. This could be instructive because you would like to construct an information system where you would like to describe menus where people select some choices, and when they choose a choice, they go to some particular page. That page may be a form in which you fill up information. That page may be a report which is generated by running an SQL in the absolute sense of information system. But simple things here without any SQL, without any connectivity can be shown to be extremely useful. JavaScript is another programming paradigm. It is not Java programming language, although the scripting resembles Java as well. JavaScript, just as the browser must understand HTML, every browser must understand JavaScript. It does not require Java compiler to sit on your machine. So JavaScript is something similar to Java, but it is a scripting paradigm which was defined by Netscape. Again, Mark Andreessen. So he said that every browser should be able to understand this script. This script actually permits collection of input through forms, permits local validation, and permits interaction with the server. So the very basic of constructing a modern application where the front end is browser and back end is either a database server or whatever was actually created by Mark Andreessen in its original conceptual. Consequently, JavaScript is almost the standard way of using some simple applications at the front end. Again, we are not going to describe the JavaScript, but the JavaScript is embedded in HTML pages itself. And every HTML interpreter, namely a browser, must understand the JavaScript commands and must execute those JavaScript commands as well. So browser is interpreter for HTML and JavaScript. This is how you write JavaScript. There is a language attribute. So you say script language equal to JavaScript /script. Inside this what you write is actually a program in JavaScript. It is not called a program because it is not compiled conventionally. It is called a script because that script is interpreted by the browser and immediately executed. But JavaScript involves fairly good amount of programming. If you want to do that, you are welcome to study JavaScript and use it. We are not going to discuss that any further in this course. There are variables which can handle values. There are methods which permit manipulation. There are rich programming constructs. There are dialog boxes such as alert, prompt, confirm. But let me just conclude this by saying, earlier I used to spend a lot of time in describing JavaScript and having exercises on JavaScript programming, I realized that that is not really important from constructing information system point of view. But those of you who want to construct simple applications by yourselves, you might do well to learn JavaScript. It's a simple scripting paradigm. It permits you to connect to a backend database. It permits you to validate user input, define forms, and it permits you to interact with the backend database to extract information, update information, etc. So if you want to do a simple homegrown application, which is not just any text files at the backend but proper database, you can do that easily by using database, JDBC, and the JavaScripting that you have. There are some simple methods which are available which can help you connect that. But otherwise, as far as this course is concerned, a knowledge of JavaScript programming is not essential at all. However, HTML is something I would like you to understand.